Yeah, yeah, good evening all. So in the last session, just we have discussed about single node multi-broker architecture. Yeah, hope everyone have understood what is partitions, replications, and how lead replica and master, that is lead and slave replicas. For example, in Kafka, think that 1,000 brokers are there. Assume 1,000 brokers are there. So before this, okay, number of replicas, equal to 3. Number of brokers, equal to 4. If one broker down, high availability possible or not? High availability.
Yes, sir.
High availability is possible. It maintains three replicas. Means three replicas means if one broker down, high availability ability is possible, means if 1 2 3 broker 1 broker 2 broker 3, suddenly broker 1 down, still broker 4 is there, the same replicas can be maintained. It maintains three replicas. If one more broker down, then high availability not possible. High availability is not possible. It can maintain only two replicas. It maintains only two replicas. If 1,000 brokers are there, assume if 1,000 brokers are there, if 997 brokers are down, high availability possible or not? Still 1,000 brokers, almost 97% of the brokers are down. Still high availability. Still high availability is possible. Fault tolerance is possible. If 998 brokers down, if 998 brokers are down, high availability, high availability, high availability means nothing like fault tolerance is not possible. Okay, so here still high availability.
Sir, I have a question.
Yeah.
In case of a large number of brokers with, in this case, replica equal to 3, there is a possibility that certain number of brokers doesn't have any replica for any of the topics.
Mm.
Because when you have 3 replicas, and let's assume we have 10 brokers, the 3 replicas will get spread only on 3 brokers, correct?
Yes.
And the remaining 7 brokers will not have any of those replicas.
Yes.
So in case if the 7 machines are down, they may have some replicas for certain topics, but they may not have replicas for certain other topics which were not there. So it will be partially things will work, but partially things will not work, correct? Or
Now, three replicas means, for example, three. For example, 10 systems. As you said, you have got 10 systems. Okay.
correct,
In 10 systems, you are maintaining 3 times replication. 3 times replication you are maintaining means in three systems you are maintaining.
correct,
So for first say, for example, think that system one is down. System one is down means, okay, for example, S1, S2, S3, in only 3 systems you have stored the data,
correct.
and replications available in multiple 3, 3, 3, 3, 9 times. Means 3 into 3 times replica means in 9 systems you have stored.
Okay,
And 3 times replicated means how many totally? 9 times.
correct.
For okay, for example, if one system down, still that replica is created in another 10th system. Means 1 second. Broker one, this broker one. See, for example, out of 10 systems, only 3 systems are available. You think only these three are available. Remaining 7 are down. So three replicas. Any partition you think, in either topic one, partition one, 3 replicas, topic 2 partition, topic 1 partition 2, 3 replicas, topic 2 partition 1, 3 replicas, any partition replicas. For example, this is b1, b7, b8, b9, b10. Actually b8, b9, b10 was empty, you think, as you said.
Correct.
Topic 1 partition 1, replica 1 is available in system 1.
B1,
Okay,
B1 in that.
in b1 it is available.
Yeah,
B1 down, then
yeah,
what it will do, it should maintain every time 3 replicas, right?
correct.
High availability, it will just it will maintain this replica here, t1 p1. Similarly, if b2, in b2, if again one more is down, so in extreme case, always if b2 down, b3 down, b4 down, b5 down, it keeps on maintaining c3 replicas. Think all the 7 are down, so you can see the replicas here, t1 p1.
Yeah, this situation makes sense, because it's a gradual degradation of servers. But in a scenario where it's like let's assume that 5 servers are in one data center and 5 is another data center, and that other data center power is gone, so all 5 will collapse right away, correct? So in that case we may have some losses, because it needs to have at least the, if one server is down, at least it should have at least 1 or 2 remaining replicas from which it can build the third replica again.
Yeah, so number of, see, I'm going to say the same thing here. Observe, when high
Okay,
availability, when high availability or fault tolerance is not possible, when high availability, just I was going to type the same thing.
okay, okay, okay.
Availability, when high availability or fault tolerance is not possible means, hmm, when number of replicas greater than number of brokers. When number of replicas greater than number of brokers, then high availability not possible.
Okay, got it.
High availability not possible. Fine. So here one more thing, uh, in this leader and master, multiple masters, in Kafka we can have multiple masters, and a single broker can behave like a master or multiple masters or a slave. For example, broker one is the leader for partition one, leader for what? Partition one. Hmm. Then for partition two, can broker one be the leader? It's leader for partition one, already broker one is that. Then for partition two also, can broker one be the leader?
Uh, for fault tolerant purpose, they should spread the partition across multiple brokers. Unless there is no only single broker, then that's a different case. But for a topic, every partition in the topic should be spread across multiple brokers.
Okay, generally if you have got multiple brokers, then you cannot make a single broker as a master for multiple partitions. If that broker is down, then we need to recreate multiple masters, lead replicas. So here answer is yes here. Then for partition two, can broker one be the leader? It can be yes, but priority will be given to other brokers. Priority will be given to other brokers. If you have got four brokers, and if you want three replications or three partitions are there, means you cannot make the broker one as the master for all the three partitions. When the multiple brokers are available, you can make for each partition one broker as the master. So here, but priority will be given to other brokers if they are busy. What is this? If they are busy, then this can become the leader for P2 also. Then this. Okay, understood everyone? It can become, so it can, when it can become a leader for P2, if all the other brokers are busy, or if other brokers not available, or if other brokers are busy, then only priority will be given, but direct priority won't be given to this. And here I understand these things in the last. When a partition has three replicas, when a partition has three replicas, one replica will become, if a partition has three replicas, one replica will become lead replica. One for the partition. The remaining used as backup replicas. For high availability purpose. Here also we have got the concept of giving acknowledgements when producer writing, when consumer reading also. So here always first replica is called as lead replica. Whenever you say describe, yesterday I showed you describe. Whenever you say describe, you will get it lead replica and slave. The broker, for example, the broker which is going to store read replica. The broker which is going to store read replica is called leader for that partition. For that partition. The broker which is going to store read replica is called leader for that partition. And here, for example, when producer, or for example, when producers or consumers are writing or reading from read replica, observe here, when producer or consumer they always read or write from lead replicas, right? When producer or consumer are reading or writing from lead replicas. If lead replica failed, if lead replica got failed, then what happens? Hmm.
So it will promote other replica as a lead replica, and then it will recover, recreate the third replica
Yes,
on the spare available broker.
yes. So I'll come back to that. I'll just leave some space here, and before going with that, I'll just come back to that. But lead replica, lead replica gets failed because of what reasons? Lead replica gets failed because of two reasons. When broker failed or broker down. Second, when lead replica got corrupted, when lead replica got corrupted. Okay, now when producer consumer they are reading or writing from lead replicas, if lead replica got failed, uh, okay, here I'm writing first one, writing got failed. Then what happens? Leadership will be changed to leadership will be changed to another broker. Leadership will be changed to another broker, which contains what? Which contains backup replicas, which contains slave replicas or backup replicas of current partition. And second, what happens again? Immediately, one more replica, one more replica of the same, one more replica of the same partition, to be allocated, in another available broker, in another available broker. Non-local. Non-local means non-local means which is not containing P1 replica. Okay. Always Kafka maintains. Always Kafka maintains assigned number of replicas. In Hadoop, it is not possible to maintain. If it is down, then it's for example, I got a query. See the fourth point. After 1 hour, if broker one is up, if after 1 hour, if broker one is up, then will it be the leader again? After 1 hour, if broker one is up, it's
No,
hmm, its leader is suspended. Its leader is what? Suspended. It won't be the leader. It won't be the leader. It won't be the leader for that partition. So here partition R1 replica 1. So its leader is it won't be the leader for that partition replica 1. That is I am saying like farmer. Farmer means previously it was that partition 1 R1 farmer is in deactivated state. Is in deactivated state. Partition R1 farmer is in deactivated state. Understanding if once it is down, okay. Now we need to perform cleanup activities. Deactivated replicas. So we need to perform what cleanup operations to remove deactivated replicas. Understood, everyone? If it is up again, it won't be that leader again.
Also, sir, if you have multiple brokers,
Hmm.
does it maintain some type of load balancing so that every broker is equally utilized?
Yeah, broker. What is the broker? One second. I was saying like in the when I was discussing architecture, KAFKA architecture. What is a broker responsibility? Just like Hadoop master, right? Assignments, even load balancing also it does.
Okay.
Now, if you observe here, one second. Refer figure one now. They forward the notes of Bloom theory Word document. Okay, one second. Okay. Now observe this diagram once. Yeah. Partition one, replica one. Partition one, replica two. Partition one, replica three. This is broker one. This is broker two. This is broker three. This is producer one, consumer. This is star, lead replica, master replica. Producer writes into this, writing messages, and gets acknowledgement. Gets acknowledgement. If broker one is down, if broker one is down, If leader is changed, then if leader is changed, if broker one is down, then producer writes into which? If broker one is down, then producer writes into, previously it was writing into this. Then producer writes into second leader. To second leader. Producer writes into second leader, then who gives this information? How how producer will come to know and how all this maintained? This information is given by whom? Zookeeper. This information is given by whom? Zookeeper. So how this why how producer is writing into second broker? How it comes to know all this information is given by zookeeper. Okay, I'm saving this file. Now, generally consumer applies n number of threads. Consumer applies n number of threads to read data from a topic. Generally, consumer applies n number of threads to read data from a topic. What is n here? Where n is, why only n number of threads? Where n is number of lead replicas. Where n is number of lead replicas.
And that will also be equal to number of partitions a topic has.
Where n is number of lead replicas means if okay, partition 1, okay, partition 1, partition 2, partition 3, partition 4, 4 partitions,
4 lead replicas.
4 lead replicas.
Okay.
So 4 threads required to read data from a topic. For example, okay, where n is number, okay, to understand this is one example. See this example. Topic 1 is the 10 partitions. Topic 1, 10 partitions. 10 partitions means how many lead replicas? 10 lead replicas.
And lead replicas.
10 lead replicas. Okay. Then 10 then how many threads required? Then 10 threads required. Then 10 threads required to read. Okay. We can also increase the thread count. We can also increase the thread count to improve the speed. Now refer figure 2. Now observe this. Now observe here. Lead replica P1 R1, lead replica P2 R1, lead replica P3 R1. So here what I do, 3 into 3, that is equal to 9. What is this 9? 3 means what? Partition. What is 3? Replicas. 9. Now can you please say how many threads required? How many threads required to read this?
Minimum 3.
Yeah. Thread 1, thread 2, thread 3. Thread 1 reads this. What are these? Topics. Thread 2, thread 3. Right. For example, first time thread 1 has read. Okay, it was read. Second time, if it wants to read, from where it reads, from where it is left out, from where it is left out. Nothing but checkpoint, we say. Second time, if it wants to read, it will read from where it is left out initially. Checkpoint. Okay. Understood this, everyone? Threads here. 10 topics, 10 partitions you assume, then 10 replicas, lead replicas, then 10 threads required.
Sir, no sound.
Yeah,
Oh, okay.
was muted, I think. On each lead replica, multiple threads can be applied. On each lead replica, multiple threads can be applied. T1, T2 thread. So message 1, message 2, message 3, message 4. When T1 fetches the first message, applies checkpoint. Simultaneously, T2 fetches the message 2 and applies checkpoint. Then once again, what happens? T1 fetches message 3 and applies checkpoint. See here? So T1 first it reads message 1. Meanwhile, when T1 is reading message 1, it fetches message 3. Sorry, message 2, right? Then again T1 fetches what? Message 3. Again T2 fetches message 4. Understanding? When T1 fetches message 1, applies checkpoint. T2 fetches message 2 and applies. T1 again fetches message 3 and applies checkpoint. On each read replica, multiple threads can be applied. Okay. Now see this. This is producer. Lead replica. This is read replica. Topic 1, partition 1, replica 1, start. Producer writes always writes into lead replicas. Writes and gets acknowledgement. Gets acknowledgement. And the same thing, for example, this is slave replica or backup replica. Backup replica or slave replica. And this is producer writes into lead replica and copied into. And here one more backup replica. Copied into this. Topic 1, partition 1, replica 3. Okay. Acknowledgements can be either 1, 0 or -1. Acknowledgement can be either now here I'm writing acknowledgement options. Producer acknowledgement options. If acknowledgement is 1, if acknowledgement is 1, producer will get acknowledgement only if message perfectly written. Will get acknowledgement only if message written into lead replica. Acknowledgement 1 means what? Otherwise, what I can say, acknowledgement 1 means producer will wait until the message is written. Message is written into lead and backup replicas. Is written into lead and backup replicas.
So basically, the replication is synchronous in nature.
Hmm?
The replication is synchronous in nature, so it will write to the lead and make sure it is able to write to all the replicas before it sends an acknowledgement.
Yeah. There are 3 acknowledgements are there: 1, 0, and -1. Acknowledgement 1 means until it writes into backup replicas, until then it waits. But acknowledgement 0 means producer won't wait. Producer won't wait.
So it will just write to the lead replica and move to the next message.
Producer won't wait until message is written. Producer won't wait until message is written to backup replicas. It waits until what? Understood this? It waits until the message is written into lead replica. It won't wait until message is written to backup replicas. But acknowledgement 1 means it will wait until it is written to lead and backup replicas, but it waits until only lead replica. For example, here I got one query here. Before copying before copying into backup replicas. Before copying into backup replicas. If the lead replica, where it is writing? Okay. Before copying into backup replicas, mm, before copying into backup replicas, if the lead replica fails, if lead replica fails, then before copying into backup, if lead replica fails, you think, then another backup replica, then another backup becomes lead and gives acknowledgement. And gives acknowledgement. So here, what is the observation? What is the observation you made here? Here, it don't care. It don't care about what? Here, it don't care about whether message copied, whether message copied. Here, it doesn't. It don't care about whether message copied into backup replicas or not. Whether it is written into backup. But here acknowledgement equal to 1 means it waits until it writes into backup replicas also. But here it won't care whether it is written into it. Just if it is written into lead replica, that's enough. Then if acknowledgement equal to -1 means what? Here producer won't wait for any acknowledgement. Producer won't wait for any acknowledgement. It goes with next write. It goes with next write.
So these settings are configurable, like we can configure the how the acknowledgement should happen.
Hmm. Yes, here we are writing in the configuration files.
Okay.
So here producer won't wait for any acknowledgement. It goes on, it goes with next write, next write, next write. And here acknowledgement -1 means here no guarantee that the message is delivered or not. No guarantee that the message is delivered or not. Okay, fine. These are acknowledgement options.
So the best option is acknowledge is equal to 1. Then the second best is 0, and then the last is -1. Acknowledge 1 is the full proof because it will always have
One is highly
very
safe,
safe. Okay.
and -1 is what? It's very faster, high
High
speed,
speed, but
but it is
you
risky.
might lose the data.
Zero is what? Moderate speed. High availability is missing, but in zero high availability is missing because message is written into lead replica only. In zero, what is the drawback you see? High availability is missing because message is written into lead replica only. It won't wait until it backup replica. In -1, very risky. No message guarantee. In one, it is highly safe. It's safe. These options we can choose in configuration file. So zero can be applied for what? For non-sensitive data, like social media tweets, web blogs, data which is non-sensitive. For this types data, we can use zero or -1 because everything, even though some messages are missed, even though if you think some messages are missed, our analysis can be performed over data. But for commercial data, we go for what is it? Option 1. Okay, fine. Okay, still there is some discussion to be made on this. Okay, fine. I'll just stop here for today and meet you tomorrow.
Sir, can you send me the link to download the VM image? Initially, you had sent us. Some of my computer crashed and I lost the image as well as the VM.
Okay. You can just once again you can personally mail your mail ID.
Okay, I will do that.
Okay, that I'll discuss once. What is data set and how to convert yes. Even data set concept I'll discuss.
Okay, thank you.
Data set is a combination of data frame and RTD. See, when I was discussing Spark SQL, I said what after data frame we got data sets. Data sets means both RTD and data frame. Data set equal to DF plus RTD equal to data set. There are some cases where data frame you cannot perform some operations like conditional operations. In that case, you can go for RTD. Okay.
Last time one interview is asking sir this question. That's why I can ask.
Yeah.
Okay.
Data sets, they should have said like data set is a combination of both the RTD and data. RTD plus DF equal to data set. Okay. Once again, I'll discuss that with some example. Okay. I'm stop here. We'll continue tomorrow. And